So hello everyone, welcome back to my YouTube channel Hasta Education. So in this video I am going to discuss about the magnification in case of a spherical mirror. Okay, so let's get started. So before getting into the main topic, let's first of all see what is an object and what is an image. Alright, so object in optics. Okay, so object in optics is defined by the help of a incident rays. Okay, this is a very interesting point. In optics, we define the objects by the help of incident rays. Alright. So object is nothing but the point of intersection of incident rays. Okay, it is the point of intersection of incident rays. Okay, so whenever you want to find out the position of object, you have to focus on the incident rays. Alright. So whatever is the point of intersection of incident rays, that will be your position of object. Alright. So how to identify incident rays? So in case of incident rays, the direction of arrow is equal to towards the mirror. Alright. Okay, so to find out the position of object, you have to focus on those rays whose direction of arrow is towards the mirror. Alright, and you have to find out their point of intersection. Okay, so object is the point of intersection of the rays which are coming towards the mirror. Okay, we can say that it is the point of intersection of the those rays which are coming towards the mirror. Alright, so it is basically the point of intersection of incident rays. Alright, so the object can be of two types. It can be real object and a virtual object. Okay, so a real object is formed by the actual intersection of incident rays. Okay, it is formed by the actual intersection, okay, of the incident rays. Okay, or we can say that it is the point of intersection of diverging incident rays. Okay, it is very important. It is the point of intersection of diverging incident rays. Okay, in the case of real object, the incident rays are diverging in nature. Right, and the real object is always formed in front of the mirror. Okay, this is very important. Okay, in front of the mirror. Okay, and in case of real object, the object distance, that is u, is always negative. Okay, so whenever u is negative, that means it is a real object. Okay, so let's see the virtual object. So virtual object is formed by the imaginary intersection of reflected rays. Okay, sorry, it is the imaginary intersection of incident rays. Alright. Okay, it is the imaginary intersection of incident rays. Alright, or we can say that it is the point of intersection of converging incident ray. Okay, in case of real object, these are diverging incident, and in case of virtual object, these are the converging incident rays. Alright, so virtual object is formed always behind the mirror. Okay, this you have to keep in your mind. And for virtual object, the object distance is always positive. Okay, for virtual object. Like, so let's see about the image. Okay, so in optics, the image is defined by the help of reflected rays. Okay, so image is nothing but the point of intersection of reflected rays. Right, so how to identify reflected rays? In case of reflected rays, the direction of arrow, okay, away from the mirror. Alright, so in other word, we can say that image is the point of intersection of those rays whose direction of arrow is away from the mirror. Okay, so now this point of intersection of reflected rays can be actual point of intersection, or it can be imaginary or virtual point of intersection. Okay, in case of actual point of intersection, the image will be your real image. In case of imaginary intersection, your image will be virtual image. All right. Now image is basically the actual point of intersection of converging reflected rays. Okay, image is the actual point of intersection of converging reflected rays. Okay, this is very important point, and it is formed in front of the mirror. Okay, is in front of the mirror. Okay, whether it is a real image or real object, that is always in front of the mirror. Okay, in front of the mirror means it is real. Okay, real means in front of the mirror. Okay, and virtual means behind the mirror. Okay, whether it is object or image. Okay, real object means in front of the mirror, real image is also in front of the mirror. Okay, whatever is virtual, that is behind the mirror. Okay, so for real image, the image distance is negative. Right. Similarly, for imaginary, image is formed behind the mirror, and for imaginary or virtual image, the object image distance is positive. Okay, now let's see the magnification. Okay, the magnification in case of concave, in case of a spherical mirror, is given by m equals to minus of v by u, that is equal to hi upon h naught ho, where hi is the height of image and ho is the height of object. Okay, it is basically the ratio of height of image and height of object. Okay, now this m can be either positive or negative. Okay, there is two possibility, it can be positive or it can be negative. All right, so when the m is positive, in that case the ratio v upon u will be negative. Okay, since m is positive, that means the v upon u will be negative. Okay, as m equal to minus v by u, since it is positive, okay, m is positive, the v by u will be a negative quantity. Okay, now since the ratio v by u is negative, therefore u and v have opposite sign. All right, now opposite sign means there is two cases. One case u is positive and v is negative, in another case u is negative but v is positive. Okay, so u is positive, that means it is virtual object, and v is negative means real image. Okay, similarly when u is negative, it is means it is real object, and v is positive means it is virtual image. Okay, so when m is negative, okay, when m is negative, sorry, when m is positive, then there is two cases. Okay, the object will be real, your object will be virtual object and image will be real image, or object will be a real object but your image will be virtual image. Okay, that means in the case of m is positive, the object and image are of opposite nature. Okay, when one is real, then another will be your virtual. Okay, that is in case of positive m. Okay, when m is negative, that simply means that v upon u will be positive. Okay, let's say m is given by minus v upon u, so when this is negative, so v by u will be your positive quantity. Okay, now since v by u is positive, that means these two have same sign. Okay, they have same sign. Okay, either both of them are negative or both of them are positive. Okay, so case number one, when both are negative, u negative, v negative, Case number 2, U positive, V also positive. Okay, when U negative, V negative, that means your object is a real object and image is also real image. Okay, when U positive, V positive, your object is virtual object and image is also virtual. Okay, that means when M is negative, it simply implies that object and image are of same nature. Okay, so let's see the conclusion. Okay, so here it is the conclusion. It is the formula of M, and it is M equals to minus V upon U, which is HI upon HO. It is the height of image by height of object. Okay, so on the basis of size, how to identify size? Now if the modulus of M is greater than 1, that means your image is magnified. When magnitude of M equals to 1, then the image is same size image. When magnitude of M, that is mod M, is less than 1, that means your image is diminished. Okay, now let's see the nature of the image. When M is negative, it simply indicates that object and image are of same nature. Okay, it simply indicates that object and image are of same nature. Same nature means when your object is real, then image will be real. When object is virtual, then your image will be virtual. Okay, and in case of negative M, your image is inverted in nature. Okay, with respect to the original. Okay, in image is inverted with respect to original. Okay, if your original object was like this in upward direction, then your image will be in downward direction. Okay, if the object was like this in downward direction, then your image will be in upward direction. Okay, M negative means two things. One thing is object and image are of same nature. That means when object is real, your image will also be real. When object is virtual, your image will also be virtual. This is the point number 1. The point number 2 is that image is inverted with respect to original one. Okay, positive M indicates that object and image are of opposite nature. Okay, by opposite nature we mean that when your object is real, then your image will be virtual. When object is virtual, your image will be real. Okay, this is the point number 1. And the point number 2 is that image is erect with respect to original. Okay, if the original object was in upward direction, then your image will also be in upward direction. If your object is in downward direction, then your image will also be in downward direction. Okay, these are the conclusion that we get from the value of M. Okay, so maximum people said that M equals to negative means it is real image. Okay, but that is not actually correct. Negative M simply tells that object and image are of same nature. Okay, either both are real or both are virtual. Okay, so let's see an example. Let's say I have M equals to minus 2. Okay, let's say I have M equals to minus 2. Okay, now what is the mod value of M? The mod value of M will be modulus of minus 2, that will be 2. Okay, and it is greater than 1. Okay, so greater than 1 means the image is here magnified. Okay, magnified. Okay, again since M equals to negative, it implies that object and image are of same nature. Okay, negative M indicates object and image are of same nature. Okay, same nature means when object is real, your image will be real. Object virtual means image will be virtual. Okay, this is the point number 1. And the point number 2 says that negative M means image is inverted. Okay, image is inverted. These are the conclusion that we get from the value of m. Okay, first of all you have to check the modulus of m. If the modulus of m is greater than 1, that will be your magnified image. If it is negative, negative means simply it says that object and image are of same nature. Okay, same nature means when your object is real, image will also be real. If the object is virtual, then image will also be virtual. Okay, negative m does not imply that your image is always real. Okay, that is misconception that I am writing down here. M equal to negative means real image. Okay, it is a misconception. Okay, m equal to negative means real image only when your object is also real. Okay, but for virtual object, negative m means your virtual image. All right, so that's it for this video. Thank you for watching this video.